Hi friends, happiness is a true sense of satisfaction that comes from hard work. Did you know that trying to solve fluid mechanics problems requires hard work? You need to think to consider various possibilities. If you do not understand the problem on the screen, watch this animation for a moment. There is a journal. It is nothing but a metal box with a hole in the middle. One end of the aluminum shaft is installed into the hole, while the other end is connected to a load via a rope. To smooth the rotation of the shaft, there is oil between the journal and the shaft. Can you guess the movement of the system? That's right. The load will pull the rope wrapped around the aluminum shaft. The rope creates a torque that can rotate the shaft. The rotating shaft has an angular velocity. Now, we are asked to calculate, what is the maximum angular velocity that can be achieved by the shaft? I think this animation is clear enough. Let's discuss this in more detail. All the values of the physical quantities have been seen in the picture, so we don't need to rewrite the values. Objects move because of forces. How about we identify what forces are acting on the system? We can divide this system into two parts. In the first part, there is the force of gravity and the tension force of the rope. While on the aluminum shaft, there is the tension force of the rope. Is this the only force acting on the system? Look again more carefully. When the shaft rotates, the surface of the shaft between the journals is in contact with the surface of the oil. The oil also moves in accordance with the movement of the shaft. The contact between two different surfaces causes friction. Let's call this force F viscous. It seems that we have found all the forces acting on the system. Now we will analyze the forces. The load will move accelerated downward according to the equation. mg minus t is equal to the mass of the block multiplied by the acceleration of the block. If you still remember, linear acceleration is the rate of change of linear velocity. Because the rope is always tense, the speed of the load is exactly the same as the speed of the rope shifting on the side of the shaft. For rotation without slipping, v is equal to r omega. Well, this omega is the angular velocity of the shaft that we want to calculate. The radius of the shaft is constant, we can exclude r from the derivative notation. This is our first equation. The two forces acting on the shaft have a torque arm of r. Tr minus F viscous r equals I alpha. Alpha is the rate of change of angular momentum with respect to time. This is equation 2. Now we will look at the part of the shaft that is between the journals. Initially the oil is not moving. When the shaft rotates, the surface of the shaft that is in contact with the oil will push the surface of the oil tangentially. This force produces shear stress on the oil. The surface of the shaft pushes the oil down, this is action. In reaction the oil will exert a force of the same magnitude, but in the opposite direction to the rotation of the shaft. That is why we describe F viscous as acting on the shaft upward. Tau is equal to F viscous divided by the contact surface area. The contact surface area is in the form of a cylindrical shell. The width is L, the length is the circumference of the circle, 2 pi r. The contact surface area is 2 pi rl. Let's say the oil is a Newtonian fluid. Then tau is equal to mu v over A. This mu is the dynamic viscosity of the oil. A is the thickness of the oil, or the gap between the journal and the shaft. When the string is not slipping, then V is equal to R omega. We can write this equation as F viscous. This is equation 3. In all of these equations, the values of omega, F viscous, and the string tension are unknown. We have 3 equations with 3 unknown quantities. I don't think we need to get another equation. The next step requires our math skills. Substitute F viscous from equation 3 into equation 2. Then, write this equation as TR. Multiply equation 1 by R. There is a TR factor here. Substitute the TR value from equation 2 into equation 1. We can rearrange this equation like this. This value is a constant value. To make it look simpler, we can represent the constant value with another value. A is equal to mgr. B is equal to 2 pi mu Lr to the power of 3 over A. C is equal to I plus mr squared. This equation looks simpler. A minus b omega is equal to c d omega dt. This is a differential equation. To get the value of omega, we can use the separation technique. Separate the equations based on those that contain omega, and those that do not contain omega. Then integrate both sides, starting from the initial condition until reaching a certain condition. The problem is that this integral is not in the standard table. We have to work around this form. Let's say p is equal to a minus b omega. So, dp is equal to minus b d omega. Or, d omega is equal to minus dp over b. For the limits of integration, when omega is 0, p is a. When omega is omega, p is a minus b omega. This looks easy. The integral of 1 over p with respect to p is ln p. The integral of 1 with respect to t is t. Plug in the upper and lower limits. Using the properties of logarithms, we can write this value like this. The value of omega is still within the natural logarithm. 1 minus b omega over a is equal to e to the power of negative bt over c. From here we get the value of omega. This is a transient equation that we often see. The maximum value of omega will occur when the value of t is approaching infinity. Thus, the factor of e to the power of negative bt over c will go to 0. The maximum omega is a over b. Substitute the values of a and b from the previous equation. This is the equation for maximum omega. We can see the values of the physical quantities on the problem sheet. Of course, we have to convert the units to MKS units. If I'm not mistaken, omega is at most about 2.08 radians per second, or 20 rotations per minute. Here's the answer to this question. Happy learning, everyone.
Yeah, I'm about to fade away, cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden I don't look at anything the same way. Got a build up of my thoughts sitting in an ashtray.